Hello, my name is Andrea Barnett, in case you haven't tuned into any other of the lectures, but this is Math 155, Contemporary Mathematics, and I am going to be doing a lecture on what we call 5.6, Rules of Exponents and Scientific Notation. That seems to be one of the biggest hurdles for some students, so if you will just hang on, we're going to do it, and if you have any questions, just email me. You should have my email address or my cell phone number, and just let me know if you have any questions about what we've talked about or what I've talked about today. So this is section 5.6. Sorry for the delay, but I was waiting for it to connect everywhere. And this section is rules of exponents and scientific notation. Now, rules of exponents are, if I was to have 3 raised to the exponent of 2, we call 3 our base, and 2 is called the exponent. Now, I see that my pen is giving out on me, so luckily I bought some new ones. Free pens at conferences don't last as long as the ones you buy. So an exponent is telling us that we take the base the exponent means that we take the base and multiply it to itself as many times as the exponent tells us. So in this case, we have a base of 3 and an exponent of 2. This is telling us to do 3 times 3, which is going to give us 9. Now, some students and some people still, they'll do 3 times 2 and get 6. Well, correct. There are some that you can do that. 2 is one of those that kind of plays tricks on you, so that's why I did the base of 3. So 3 squared, and we call this 3 squared, is going to be 3 times 3, which equals 9. Now, what if I had 3 squared, this is my multiplication sign, times 3 to the third? If our bases are the same, so when you multiply with exponents, with the base the same, then you add exponents. So this one would be 3 raised to the 2 plus 3. So this would be 3 to the 5th. Now a good way of figuring this out is 3 times 3 equals 9. 3 times 3 times 3 is going to equal 3 times 3 is 9. 9 times 3 is going to give me 27. And then if I'm adding these, I'm multiplying these together, then I'm going to say 9 times 7 is going to be 63, carry a 6, 18 plus 6 is going to be 24. And then in the lack of time here, I'm going to do 3 raised to the 5th power, and that's going to be 3 raised to the 5th power is going to be 243. So your answer should come out the same no matter. Now multiply these two together because that's what the original problem said. I didn't add them. I just added the exponents, and that gave me this. Now, this is when we multiply, when we are finding the product. And like so, this is called the product rule. Product rule for exponents. Now, the quotient rule, and for some reason my spelling doesn't want to. And quotient means that we're going to be dividing. So what if I had, let's use the same numbers, 3 to the 3rd divided by 3 squared. So since division is the opposite of multiplication, then this is going to be 3 to the 3 minus 2, which is going to equal 3 to the 1. Now, we can reduce these because we can go ahead and just take the 2 out of this one and just be left with 3 to the 1 in the numerator. If I did this, I have 27, because we just did it on the previous page, 3 cubed. 3 squared is 9. And then 9 goes into 27 3 times. And 3 to the 1 is also equal to 3. Now remember, these have to be done when you have the same base. If I had 2 different bases here raised to 2 different powers, I would have to multiply everything out in the numerator, multiply everything out in the denominator, and then reduce my fraction. Now, any number raised to the 1st power, so that's 3 to the 1, 4 to the 1, 5,250 raised to the 1 is always going to equal that number. Okay? Any number raised to the 0 power. So 3 to the 0 power, 4 to the 0 power, or 5,250 raised to the 0 power, those are always going to be equal to 1. So remember these. Anything raised to the 1 power is always going to be whatever the base is. Anything raised to the 0 power is always going to equal 1. So let's do a quotient rule. If I had 4 raised to the 4th power over 4 raised to the 4th power, then I take excuse me, 4, which is my base. I take my exponent in the numerator and I'm subtracting it from my exponent in the denominator, and that's going to equal 4 to the 0, which is going to equal 1. Now we should know that any number over itself is always equal to 1. So 4 to the 4th power in the numerator is going to be the same as 4 to the 4th power in the denominator. And so when I subtract those, I equal 1. Now, we've covered multiplication rule, we've covered the quotient rule, and the other one we just did was called the 0 exponent rule. What happens if we have something that has a negative exponent? So let's say I have 5 to the negative 2. This negative is not telling me, like we would normally think, to go on a number line to the negative section. This is telling me that I'm going into the denominator. So this means that I have 1 over 5 squared. So 1 over 5 squared then will be 1, and 5 times 5 is 25, so I have 1 over 25. Now in this case, we will not have a 0 in denominator, otherwise it's going to be undefined. So an example on page 256, and it's already given, but I'm going to work through it. We have 3 to the negative 2. This negative, before I do anything, automatically tells me I need to rewrite this as 1 over 3 squared. And that's going to equal 1 over 3 times 3, which is 1 over 9. Same thing goes as 7 to the negative 1, which is 1 over 7 to the first. And we know that 7 to the first power is going to equal 7, so it's 1 over 7. Let's do another rule, and then we'll go and look at some examples of what we need to do before we do scientific notation. So another rule, this is called the negative exponent. The last rule we're going to look at is called the power rule. Now, if I was to do something different, 4 squared, and then I was taking 4 squared and I was squaring it again, when we're doing the same base and we're multiplying, we know that we add. When I've got a base that's raised to a power and then that's raised to a power, this is called our power rule. So what we're going to do is take the base and then we multiply the two exponents together. So 4 squared squared means that I'm going to take this to 4 to the 4th. So what you're doing is you're squaring 4, and then you're squaring that number again. So we know that 4 squared is 16, so then we're doing 16 squared. So if we look at our calculators, and let's go ahead and tilt it so you can see. So if I do 4 squared is going to equal 16, and then I'm going to square that, then that's equaling 256. So 4 squared is 16, and 16 squared is 256. Instead of me having to go through that whole thing, I can just do 4 raised to the 4th power, and I get the same answer, 256. So 4 to the 4th is 256. 4 squared, 16 squared is also 256. So these rules, we can go about them and get the same answer, but a lot of times it will just take us a little bit more time because we're having to plug in more stuff into our calculator. But sometimes we can just end up doing this. So I'm going to flip over to the exercise page, and this is at page 261 in your textbook, and I'm going to do 17A, and oh, I'm sorry, I forgot one more important thing before I do this. If we have negative 4 squared, and then we have negative 4 squared, there's a difference between these two answers. The difference is, this is telling me to square the 4 and then take the negative of it. So here I would say 4 times 4 is 16, and then I take the negative. So if I wrote this out, it would be the negative of 4 times 4. So this equals negative 16. This is telling me to take negative 4 and multiply it times negative 4. So this would be a negative 4 times a negative 4, which is going to be a positive 16. So please be careful when you've got these signs. If it's in parentheses, then you're going to take it with you as you multiply, as you carry it to that exponent. If it's not in parentheses, then you're going to tag it on to the very end. Now please be careful when you're reading your problems, because sometimes it may be in there and sometimes it may not. And the reason I backed up was because the problem I want you to look at is actually one that has this. So page 261, number 17, we have A, which is negative 9 to the negative 2, and B, which is parentheses negative 9, close parentheses, to the negative 2. So this one, I'm looking at several different things here. First thing I'm looking is at this negative exponent. The next thing I'm going to notice is that I'm only raising this 9 to this negative exponent. So I'm going to have a negative 1 over 9 squared. And 1 over 9 squared is going to give me a negative 1 over 81. Now in this problem, it's telling me to take the negative with me, and I'm going to actually square that. So I'm doing 1 over negative 9, still in parentheses, squared. And we know negative 9 times negative 9 is going to equal a positive 81. So then we have 1 over 81. So you can see the difference. Notice here that I put, even though I didn't put the negative down here with the 9, it's still here. Whether the negative is in the numerator or the denominator, it still makes the whole fraction negative. The only time I would get rid of the negative here is if I had a negative over a negative, and then they would cancel out. So let's do number 20 on that same page. And 20A is saying that I have a fraction, and I know people just love fractions, so that's why I want to do one. 1/2 squared, I'm making sure because I've got brackets here, and parentheses, to the negative 3. No, sorry, just to the 3rd. I'm going to make that a positive 3. Probably help if I pull my glasses out, wouldn't it? And then B is actually going to be parentheses, a negative 1/2, close parentheses, squared, and then this will be a bracket here, raised to the 3rd. So in this first one, I know that I'm taking a power and raising to a power. So all I want to do is just work with this. And I know it'll tell you to go from the parentheses and work out. But our parentheses are telling us we're going to keep this just like this at 1/2. Our exponents are saying that we have 2 times 3, which is going to be to the 6th. And I'm putting this in parentheses, to the 6th power. 1/2 to the 6th power. This is saying that I have a negative 1/2 in parentheses, and I'm taking my negative 1/2 also to the 6th power. Now, instead of you having to go, okay, I've got 6, so I've got a negative times a negative is going to make a positive, a negative times a negative is going to make a positive, a negative times a negative is going to make a positive. So I end up with a positive. If you have an even exponent and you're multiplying it with a negative number, you're always going to end up with an even number. An even exponent to a negative number gives you an even number. A negative number raised to an odd number, that gives you an odd, you're going to keep it negative. So 2 to the 6th power is actually 64. So this is going to be 1 over 64. And this will actually equal 1 over 64. So you have 2 different ways of getting, and we got the same answer. So I'm going to come back and on another video and do the scientific notation. I hope this helps. If you need some more clarification, have a question about a problem, please let me know and I will help you out.